So today we're going to talk about negations. And we're going to talk about the inverses and contrapositives of conditional statements, and then one quick little piece of information on indirect proofs. Okay? All right, so here we go. Let me grab a marker instead of that. Here's the statement, the light is on. And we want to negate that statement. Okay, so what would we write to negate the light is on? What's that? The light is off. Okay, I agree with that. Because the light is either on or it's off, right? Unless we get into some tricky area like during a brownout. You know what a brownout is, right? Yeah, it's a blackout is when you lose power and everything shut down, but a brownout is when power is not where it needs to be and things are just barely on. So the lights are half lit. That's the way it looks. Okay? I'm sorry, one quick guess here. All right. So that is what a brownout is, and so we could get into some iffy land there if we just think on or off. All right. How about my shirt is gray? What's the negation of that?
My shirt is not gray.
My shirt is not gray. Okay? I totally agree with that. My shirt is not gray would be in the negation of that. Okay, again, it's either gray or it's not gray, right? How about the statement 6 is greater than 6 is greater than X. 6 is greater than X. That's my statement. Yeah.
X is greater than 6.
Okay. Okay, we're hearing a lot of options here. So let's write down the options. We'll put them in red. We heard X is greater than 6. We heard 6 is less than X. And we heard 6 is not greater than X. Did I hear anything else?
Could you say 6 is equal to X?
6 is equal to X. Okay. Now, what we're getting into is kind of like that brownout. It's a little bit trickier here. The difference is when we negate a statement, sometimes there's a word that replaces the word we're using. Like, for example, when we said the light is on, the only way to change that is to say the light is off, right? But sometimes there's other symbols like we have here. We have greater than, we have X is greater than, we just switch those two around. We have 6 is less than. These actually say the same thing, don't they? Okay? Saying these two actually say the same thing. And then we have 6 is not greater than X, and we have 6 is equal to X. Okay? Pick some numbers that are in this set right here. 6 is greater than X. What's that?
6, 7, 8, 9, 10.
No, I don't think those work.
Oh no, I'm thinking.
1, 2, 3, 4, 5.
I was thinking about
5.5. What? Anything that's less than 6, like negative anything, right? Okay? How about 5.9999999? Okay? How about 6? 6 doesn't work, okay? And 6.1 doesn't work, and 7 doesn't work. And so it's not only, to be part of this set, it's not only has to be less than 6, it can't equal 6 either, can it? Okay? So, almost always, the best way to negate a statement is to use the word not. Because then we don't have to worry about situations like this, okay? This one is a good way of saying it. 6 is not greater than x. None of the rest of these would work. Now I could say x is greater than or equal to 6. That would work. Or 6 is less than or equal to x. That would work also. Okay, those are saying the same thing. Any of these 3 here would work to negate that. All right? But almost always, this is the best way, to use not. Okay? Almost always the best way is to use not. Let's write the definition of the negation. Negation changes the truth value of a statement. Okay? So negation changes the truth value of a statement. And again, it's best to use not. Now, if I start out by saying the light is not off, so if I take the word not out, the negation of the light is not off would be the light is off, right? So if I wanted to negate, I kind of, if we think of the word off as being a negative, we're kind of throwing in 2 negatives there, aren't we? The light is not off. It's easier to say what? The light is on. Then to negate it, we would say the light is off. But again, the better way of saying it would probably be the light is not on. Okay? In that situation, I agree, the light is either on or off. But sometimes there's some gray. It's not always black and white. Okay? Sometimes there's some gray involved. Okay? So, keep that in mind. Inverse. The inverse negates the hypothesis and the conclusion a conditional. The inverse negates the hypothesis and the conclusion of a conditional. Example. We've used this before. We said if the switch is up, then the light is on. Okay? If the switch is up, then the light is on. And we've talked about that's not always true, haven't we? Many of our houses have 2- and 3-way switches, or we have 2 or 3 or 4 or more switches to the same set of lights. Okay? Most commonly in your hallways or in opposite sides of a room that has doors on both sides, like maybe you pass through from your kitchen to your dining room to your living room. Your dining room almost always have light switches on both sides to the dining room lights. All right? So anyway, we have those situations, but I'm not worried about whether this is true or not. I'm just looking at the statement. It says, if the switch is up, then the light is on. Well, in this room, we know that's true unless there's a power outage, right? Okay, but if we want to negate this and write the inverse, okay, then we are going to switch the hypothesis and the conclusion. Well, remember, this is the hypothesis, and this is the conclusion. Okay? And so if we switch the truth value of each one of them, if we negate both of them, instead of saying if the switch is up, we're going to say what? If the, we're not writing the converse. Be careful, we're not writing the converse. I was kind of hearing that. We're going to write the inverse, which means we negate the hypothesis and the conclusion. So just look at the hypothesis. It says right here, the switch is up. So how do I negate that? The switch is not up. Okay, we could say the switch is down if it's clear that there's no other possibility, which isn't always clear with switches, right? So remember I said it's almost always best to use the word not. So I'm going to use the word not here. I'm going to say the switch is not up. Then
The light is not on.
and the light is not on. That's the inverse. And kind of like with the converse, it doesn't matter if the original statement was true or false. It has no bearing on whether this statement is true or false. Okay? The original could be false and this could be true. The original could be true and this could be false. This one here could be false. Or they could both be true or they could both be false. There's just nothing to tell. You have to judge it based on what it says all by itself. Okay? You have to judge it based on what it says. All right, so let me give you another one here, and then you try to write it. Let's do something that you'll be excited about. Pause while you, try that.
I think we should go the last week.
So, sorry we started without the recording going, but we were talking about whether this is a true statement. And we're saying, assuming the timing was right, so it was hit just perfect in the morning, and the 10 inches was done by 6 o'clock, and we agree this would be a true statement then. So if we write the inverse of this, girls, if we write the inverse of this, we would say if, Maya, what'd you say? Okay, I see I had a grammar error there. Yeah, well, sometimes that's not necessary. But anyway, if tomorrow's storm, I'm sorry, I couldn't quite hear you either, so I'm sure the recording can. If tomorrow's storm what?
Does not drop 10 inches of snow, then we will have school.
I'm gonna shorten that for you. It doesn't drop 10 inches of snow. Then what'd you say?
Then we will have school.
Then we will have school, okay. I totally agree with what you're saying. Then we will have school. So if tomorrow's storm doesn't drop 10 inches of snow, then we will have school tomorrow. Do we agree with that?
Yes.
So you think that's a true statement also?
Not always.
Oh, come on now, yes or no?
Yes.
No.
Yes? What if we get 15, is that 10?
Yes.
No.
Yeah.
It's 15 and then some, 10 and then some.
Yeah, but is it 10?
No.
It's more than
If I get 15, that would, if I got 15, that would satisfy this part of the statement, right? If tomorrow's storm doesn't drop 10 inches of snow.
Yeah.
If it drops 15, it's not 10, right?
Halfway.
So you see what we're getting at here. We have to carefully evaluate this all on its own. At first glance, you might be thinking, well, if we don't get 10 inches, because we're assuming we're getting less, right? But even then, what if we get 8? Oops, best be shutting that down.
I get 8.
Okay?
Total whistle.
Maybe that's school Facebook saying, we're getting a storm, we're heading home.
Probably my dad.
I'm leaving today at noon. All right. So here's my point. Come back to me. So my point is, this first part here can be true, and the second part be false. All right, very easily, because we could really exaggerate and say, what if we got 50 inches of snow tonight or tomorrow? Then we're definitely not going to have school tomorrow, or probably the next day, or the next day, or the next day. Okay, it might even be next week before we had school again. So the contrapositive takes the converse of the inverse, or the inverse of the converse. Either way, we get the same statement. If we negate both the hypothesis and conclusion of the converse of a statement, we get the contrapositive. Or if we negate both the hypothesis and conclusion of our original statement and then write it as its converse, we would still get the contrapositive. So what we're going to do to find the contrapositive is we're going to take the converse of the inverse, or some of you might prefer to think of it as the inverse of the converse. Okay? For me, it's usually easier to think of it the first way, but it doesn't matter. They both will end up exactly the same place. Okay? If I walk out my driveway and I turn left and go a mile, and turn right and go a mile, and turn right another mile. Yeah, left, right. Okay, I'd end up right there. So if I walked out and went right a mile, left a mile, left a mile, I'd end up right there, wouldn't I? The same place. So my point is, you're going to end up exactly in the same place whether you're taking the converse of the inverse or whether you're taking the inverse of the converse. We're going to be in exactly the same statement. All right? So let's go back to the storm. And let's write that statement down again. I'm going to pause to write it. So our statement again, same one we used before. If tomorrow's storm drops 10 inches of snow, then we will not have school. Okay? So I want to write the contrapositive of that. I want to write the converse of the inverse. And so the contrapositive is going to say what? Well, what's the inverse of this going to say? Okay, if tomorrow's storm doesn't drop 10 inches, then we will have school. So if I just modify this right here and I say, okay, let's take that out, and let's insert the word doesn't. Okay? What's that? Okay. And we write the contrapositive. Now this is the inverse, right? If I throw this doesn't in there and take out the not here, okay, then we have the inverse, right? What's the converse of that going to say? If we have school tomorrow,
then tomorrow, or then tomorrow's storm drops, or doesn't drop, then you don't care.
then tomorrow's storm
Don't you mean like yesterday's storm? Yeah.
if we have school tomorrow, then tomorrow's storm what?
Will not drop.
Will not drop 10 inches on us. Right? Okay, do we think that's true? If we have school tomorrow, then tomorrow's storm will not drop 10 inches on us.
Not necessarily.
What's that?
Not necessarily.
If it's way out.
So do you think we can have school tomorrow and the storm drop 10 inches on us?
Well, I mean, we
Depends
couldn't
on
have
when,
school
how
tomorrow.
many storms are going.
Like, there could be a condition where we didn't have school tomorrow.
Oh, hold on. For this to be true, you've forgotten, I think, what it means to be true. For this to be true, this part has to be true. Okay? So for this to be true, then we have to have school tomorrow. Or whether it's false, either one, we have to have school tomorrow. Okay? To determine whether it's true or not, the hypothesis has to be true. Okay? So to judge whether this is true or not, we have to have school tomorrow. Either way, whether it's true or false, we have to have school tomorrow. Now, for it to be false, we would have to have school tomorrow and get 10 inches of snow, because this says we will not get 10 inches of snow. So for this to be true, or false, I mean, we would say we have school tomorrow and we got 10 inches of snow. Do you think that's a false statement? We kind of already said that if we get 10 inches tomorrow, then we will not have school, right? This is saying exactly the same thing. This is saying we have school tomorrow because we did not get 10 inches of snow. Okay? And so, what I want you to understand, and sometimes it's hard to come up with all the examples to prove why this is true, but this is absolutely a true statement. The conditional and its contrapositive are either both true or Okay? It is not possible for one of your statements to be true and the other one false. Now that's not the case for a converse, is it? In the converse, my original could be true, but when I flip it around, it could easily be false. Or the other way around. My original statement could be false, but when I flip it around, it's a true statement. And with the inverse, that could happen. I could have one statement true and the other one false, or the other way around. But with contrapositives, either the original conditional is true and the contrapositive is true, or the original conditional is false and the contrapositive is false. Okay? They are both true or both false. Now be careful. If I ask you this question on the test, all right, and I say, I ask you if the contrapositive is true or false based on the conditional, then sometimes people just take out the words both and they say, yeah, it's either true or false. Well, that's too vague. What do you mean by it's either true or false? That's true of every statement. It's either going to be true or false. I could say Jet just got a 400 points on his test. That statement's either true or false. Marty just shot a 1 point this weekend. Okay? That's either true or false, right? So don't just carelessly take out the words both, because these have to be hooked together. They are basically saying exactly the same thing. They're just written in a different form. Okay? So they are identical statements to each other. They just look differently. It's kind of like doing this in math. 5x minus 7 equals 12, and then the next statement is 5x equals 19. We say those are equivalent statements, right? Well, that's what we're saying here. The contrapositive and the original conditional are equivalent statements. They have exactly the same truth value. Okay? Exactly the same truth value. All right. Let me pause for a minute. All right. Indirect proofs. In writing an indirect proof, there's 3 steps we want to follow. Okay? 3 steps to write an indirect proof. The first one is state the assumption that negates what we want to prove. Okay? State the assumption that negates what we want to prove. And so in this statement here, what do we want to prove? What's it say? What do we want to prove there? Okay, that the square root of 8 does not equal 2.8. That's what we want to prove. So how do we write the negation of that? Okay, so we're going to say, let's assume square root of 8 is equal to 2.8. Okay? We're going to assume that square root of 8 is equal to 2.8. Okay? Step 2. Use good math logic to prove your assumption is true. Okay? Use good math logic to prove that your assumption is true. put a comma there actually. Until you find a contradiction. Alright, now just to make sure you're clear what I'm saying, in step 2, use good math logic to prove your assumption is true. You really have to try to sell this. Okay? It's like when your little brother and sister won't eat their peas and you want them to. Probably all of you have done this. You try to make them think you don't want them to eat their peas, right? Because you want to save them for yourself. What do we call this? Reverse psychology, right? That is very much what indirect proof is about. We try to go the other way around. I've been arguing with Kimberly that she needs to do her homework and study hard, and she's been trying to prove that she can do it without doing her homework and studying hard, and so I realized I'm not getting anywhere that way, so I go around the other way. I says, I don't want you to do your homework. I would love to have you back in my class next year. Okay? So if she bombs out, then she'll be back next year, and so I could use that approach, the reverse psychology. Try to go in from the back door and make them think you want something other than what you really want. Same thing's happening here. You're done arguing with somebody, trying to go straight at it, so you're going to come in from the other way. You're going to say, well, let's assume what you're saying, Kim, is true. Okay? I just made it up. So I say, let's assume what Kim's saying is true and that she doesn't have to do any of her work. She can do just fine. And I would then say, okay, so then I agree with you. It's going to be okay. So when I do a notebook check for you, you're going to get a 0 and she'll say, yep. And I say, when you take your quiz, you're going to lose all your homework question points, so your quiz is going to be lower. Yep. And so then I'd say, when you take your test, there's certainly going to be questions you don't get, right? And she says, yep. And that's okay. And then I say, well, let's add up the points. And when I add up the points, out of 100, if she's less than 60, then what did I just show? That we're no longer passing, right? And so that's where the contradiction comes in. In this case, let's do this one together. Let's assume square root of 8 is equal to 2.8. Okay? Then, square root of 8 squared will equal 2.8 squared. Do you agree with that? Is that sound math logic? To solve, to get rid of a square root, we can square both sides? Do you agree with that, RJ? Is that legal to do this? Yeah, okay, I agree, it is. And so, that gives me square root of 8 squared. Square root of 8 times square root of 8 is square root of 64, which is 8, is equal to what? So I need your calculator now. What's 2.8 squared?
7.84.
7.84. Oh, wait a minute. Is 8 equal to 7.84? Close, but is it equal? I mean, this statement clearly says equal, not close, right? It's not horseshoes or hand grenades. It is equal, okay? So we'd say that's not equal. 8 is not equal to 7.84. Therefore, square root of 8 does not equal to 2.8. Okay? And that leads us to our last statement that says, then conclude. Oops, can't spell conclude. That the assumption
We're supposed to say then conclude.
then conclude that the assumption is false. And what 3 steps. Step 1, state the negation of what you want. Assume the opposite of what you really want. Step 2, Step 2, try to prove that assumption is true until you run into a contradiction. And then step 3, conclude that the assumption must be false and what we really wanted to prove all along was true. Okay? This didn't write that very well. Do not know why. Have to write slow when you're recording. It takes a long time to process. All right? Now, on the test, probably there would be something very similar to this, some math type thing that would be easy to show true or false. Okay? In the homework, there might be other things. Okay? And you may have to make up a story like I was with Kim and kind of go around that way. All right? Just to practice the concept a little bit. What I want you to understand is, for sure, is those 3 steps of an indirect proof. And then, am I writing this in 2-column form? No. I'm going to write this in just a paragraph form, and it's probably only going to be a couple sentences. All right? So indirect proofs, not at all like we were doing last chapter. Much easier, much more straightforward, as long as you understand these 3 steps. Okay? Let me pause while I make sure I know what your assignment is. As you see, I changed this from, instead of 1 to 55, it's 1 to 37 today. Odds. And tomorrow it's going to be 2 to 38 evens. And then tomorrow, remember, we have a quiz over lessons what?
1, 2, and 3.
1, 2, and 3. And it's the only quiz of the chapter. And our test is on Friday. Okay? So let's make sure that we get caught up if we're not and stay on track. Should be an easier test. There'll be more review in it. If you're still getting some of those other questions wrong, then sometime this week see me about your old test so that we can go over some of the ones you're getting wrong. Try to fix them. Okay?